All right, here comes our second part to our Unit 10 review. Starting with number 25, we have another composite figure, and it is made up of a triangular prism and a rectangular prism. And so when I look at this and I think about surface area, I think about painting the surfaces that I would see. And the surfaces that I would not see is I would not see the bottom rectangle on the triangular prism. I would see both bases, and I would see this rectangle here and the rectangle in the back, but I will not see this bottom rectangle. And then for the rectangular prism on the bottom, I would see everything except for the top rectangle, which I could call the top base. So this is what I have going on. I have the surface area of the triangular prism, but it's missing a rectangle, and it's missing this rectangle down here that is 8 by 15. And then I have the rectangular prism without that top rectangle, so it's a rectangular prism, but it's only got one base. It's only got its bottom base, it won't have its top base. So this is what I'm going to do. This is your formula for surface area of a prism, an entire prism, but I'm taking away 120 because I can't paint this rectangle here. That surface would not be there to paint, and 15 times 8, length times width, is 120, so I'm taking the 120 away. And then this is our formula for surface area of a rectangular prism with only one base, because typically it's a 2B, but because I don't have the top base, then I change it to a 1B. Okay, that's the game plan. Now let's get going. So first thing I need to know is perimeter of the base for my triangular prism. And so the perimeter of the base, I know that this is 8, I know this is 8, and with a little thought, I know that this is 8. So the perimeter is 8 plus 8 plus 8, and 8 plus 8 plus 8 makes 24. So capital P is 24. And then capital B is the area of the base. So I need to figure out the area of this base. So I went ahead and I drew in the height. I know that little piece is a 4. So then I just did Pythagorean theorem here. X squared plus 4 squared is 8 squared. But I also could have treated this as a 30, 60, 90 triangle, like I did earlier on one of the earlier problems. Anyway, I got my height to be 6.9 approximately. When you go to find area of your triangle, you take base times your height and divide by 2. And that's what I get for the area of my triangle, which is the base of the triangular prism. So that's going to go into capital B. So let me show you. So the perimeter is 24. The height of the prism is 15. That's how tall it would stand if you set it up on its triangular base. Capital B is the area of the triangle, 27.6. Okay, so now working on, and then don't forget you have to take the 120 away because you don't have that bottom rectangle. Okay, I'm going to go ahead and go to the rectangular prism. Quite honestly, any of these surfaces could be the bases. I had the bottom be the base, so 8 times 15. Oh, I'm sorry, capital P, perimeter of the base. So if I want to find the perimeter of the base, I add 8 plus 15 plus 8 plus 15. That makes 46. The height of it is 8. Remember, the height connects the bases together. And then capital B is the area of the base, which is 8 times 15, and that makes 120. And then all I did was just work it out. 783.2 square feet. Okay, our next one is a composite figure as well, but it's volume, and volume is much, much simpler. So what I have going on here is if I want to fill this shape with air or with water, I would fill the entire small rectangular prism, and I would fill the entire top rectangular prism. There's no surfaces that you don't see because I'm filling this up with something. Okay, so your formula for volume of a prism is capital BH. And then I just had to do a couple things here. First, I worked with the small rectangular prism. I know if it's 12 all the way across from here to here, and I know that this piece is a 6, that piece is a 6, that this piece is also a 6. It doesn't look like it, but that's what it is. So those are 6's there. So capital B, area of the base, I call the bottom the base, and I know that this is 20, and I know that this is 6, so 20 times 6 makes 120. And then the height of the small rectangular prism is 4. That's the piece that connects the bases together. Okay, as far as the big rectangular prism is concerned, I'm going to call the bottom the base again, and I know that this is 20, and I know this is 6, so 20 times 6 is 120, and it stands 8 high. And I just work it out, and 1440 is what we get. Okay, this next one is a composite figure as well, but it's volume, so it's much easier than when we work surface area. So if I wanted to fill this whole thing up with air or with water or with whatever I want to fill it up with, I would fill the entire cone, I would fill the entire cylinder. So that's what I want to do. I want to find the volume of the cone, find the volume of the cylinder, add them up. These are our formulas. Working with the cone, I know that the cone has a radius of 4 and a height of 6. So I know everything I need to know. I just plug that in. As far as the cylinder is concerned, I know the cylinder has a radius of 4 and a height of 9. So I have everything I need to know there also. And when I work it out, this is what I get. Okay, one last page. Okay, this one, we're finding volume. And this cylinder here is cut throughout the entire box. So basically our big rectangular prism has a big hole in it in the shape of a cylinder. So if I want to find volume, I'm going to find the volume of the whole rectangular prism, and then I'm going to subtract the volume of the cylinder cutout. So here are our formulas for volume of a prism and volume of a cylinder. Let's go ahead and start with the prism. The prism, capital B, area of the base, 6 times 6, 36, and the height of the prism, 6. So I'm going to take 36 times 6. And then the cylinder, I need to know the radius and the height. The radius of the cylinder is 1, and the height of the cylinder is 6, just like the height of the prism is 6. So I plug in the 1 and the 6, and then just a little bit of calculations to do it, and there we go. If you leave your answer in terms of pi, this is how you would have to leave it. You can't actually subtract the 216 and 6 and get 210 pi, because this 216 doesn't have a pi behind it. So this is your answer in terms of pi, but this is the decimal approximation. Okay. The next several questions get into change of dimension. So number 30. It talks about your dimensions in number 3 are tripled. How many times bigger is the new surface area? Okay, so it's not asking what is the new surface area. It just says how many times bigger is the surface area. So this is when I take my change, what's happening. The shape is tripling. If it's tripling, if it's halving, if it's 3/4 the size, 5/4 the size. And then area is always an exponent of 2. The shape would be 9 times bigger. Or the surface area, I should say, would be 9 times bigger. But it didn't actually want to know what the new surface area was. Okay, 31. 31 says that the dimensions in number 12 are halved. What is the new volume? Okay, this one actually wants to know the new volume. So I'm going to take the answer I got in number 12, which is 50,000 pi. You also could have the decimal equivalent here. That's fine. The change, what's happening, is that it's getting halved. So I'm going to have 1/2 in the parentheses. And then because we're talking volume, the exponent's a 3. And if I work that out, I get 6250 pi, or approximately 19,635 cubic feet. Okay, this next one. says a circle has a radius of 24 inches and the radius is doubled. How many times bigger is the circumference of the new circle? Okay, so it's not asking what is the new circumference. It just wants to know how many times bigger it is. It's a lot like number 30. So I take the change, what's happening, and the change is 2. The shape is doubling. The radius is doubling. And circumference is like perimeter, and so that's an exponent of a 1. And so the shape will be 2 times bigger. And then I actually worked it out so you could see it for yourself. So I wrote down the formula for circumference. If the radius is 24, I put 24 in the R. When I work this out, I get 48 pi. Then I actually did double the radius like it talked about. So if I double a radius of 24, the new radius is 48. And when I work this out, I get 96 pi. So you can see that the new circumference actually is 2 times bigger than the original. So I worked it out so you could see how many times bigger it was, and then I also practiced our formula that we learned. The change, what's happening, twice as big, 3 times as big, a fourth the size. And then exponent of 1 for perimeter and circumference, exponent of a 2 if it's area, exponent of a 3 if it's volume. Okay, this one here, it wants to know what is the volume of a similar rectangular box with dimensions that are 3.5 times larger than the dimensions of the rectangular box shown. So I could draw a new shape and multiply all of these by 3.5 and then calculate the new volume and see how many times bigger it is, or I can practice what we learned the other day. So first I found the volume of this shape here. It's a prism, so area of the base times the height, and I called my base the bottom again. So 10 times 12 is 120, and then the prism stands 4 high. So this shape here has a volume of 480, so that's the original dimension. And then what's happening to it, I want it 3.5 times larger, so that's the number in the parentheses. And then because we are talking about volume, the exponent's a 3, and that makes the new volume 20,580 cubic inches. That's all. Smiley face. I hope you do great on your test. Thank you.